So if you look at management plane, then as I've already told you that the network devices of the past that's in traditional deployment also, they would be managed with the help of CLI as well independently. But Cisco's SD-WAN, however, introduces something called management plane, okay, or something called management plane with the help of a controller that's there, which is called as vManage. So management plane is a is a complete responsibility that is handled by a controller called vManage. And so vManage is basically the network management system that provides a single, you can say, point of touch to the entire SD-WAN fabric that you have. Okay, vManage can actually be utilized for onboarding purposes, for provisioning purposes, for policy creation purposes, for software management purposes, for troubleshooting and for monitoring and for doing every task that your entire SD-WAN fabric might need to be configured with. So through vManage, it, however, like vManage has kind of various other feature set as well. But if the preference is to interface with vManage in terms of automation and so, then the vManage can actually be managed. Like vManage itself can be managed by using REST API. If you are familiar about what is REST API.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So you can use like Python scripting, or you can use automation in a way that the vManage can automatically be configured by using REST API in order to communicate with it. Okay, so by having a full API support, the user can build and utilize scripts and interface with vManage in an automated fashion. And this type of API also allows the user to use the existing and future, you can say, toolkits for integration that's going to be there. Cool. So you can create your third party application and communicate with vManage in an easy way possible. And you this is kind of a dashboard image that you see over here. So you can see that you have the number of vSmarts that are up there, you have number of WAN Edges that are up there, you have number of vBonds that are up there, you have number of vManages that are up there, and you also get the information about reboot that's done there. Okay, you get to know about the control plane information, that if the controls of all these devices are up or not. Okay, so you get the information about that. You get the site health, that how your site is performing, whether do you have the full WAN connectivity, partial WAN connectivity, or no WAN connectivity. You get to know about the health of all your edge devices. You get to know about what all are the vanages that we have. So you have the inventory information of that. You have top application information that have been performing based on the traffic generation that's done in your dashboard, and you have the information about application aware routing, which actually calculates like load and jitter and delay and all, and that gives you the ability to see that which vAnalytics is actually performing the best and what's the transport type that is using and all these things. So you can see all that information onto the dashboard. However, we'll be talking about that when we will kind of deploy the solution into the lab and all. But yeah, that's how it looks like. So vManage, however, is also like highly scalable depending on the needs of the environment and so. And vManage can also be clustered, so it supports clustering. Okay, and you can provide redundancy for the clustering purposes that's available there, so that if one vManage goes down, there can be other vManage. And with multiple clusters deployed regionally and globally, you can like keep them separate for different geographical regions. But a single cluster is basically made up of three or more vManages that are available there. So one cluster is equal to 3 vManage or 3 plus vManage. That's how you create a vManage that's out there. Cool. So and you can say that the you can always like add up the number of vManages that are available there, but the number of vManage that you are having in your cluster always needs to be an odd number. So you cannot have vManage like four vManages or six vManage or eight. You cannot have that. It always needs to be either three or five or seven or nine or 11 or like that. The number always needs to be odd. Cool. And you can say when first logging into the vManage, you will actually be presented with statistics and whatever the information is going to be there, which would be your dashboard page. Okay, then on that page you will get the like basic information about how your SD-WAN fabric is performing. And vManage, of course, is highly scalable in terms of like how it performs. So depending on the needs of the environment, when vManage is clustered, then you can say the multiple clusters can actually be deployed. And if you look at that, then you can say that a cluster can manage up to 6,000 WAN edges, which means like as one cluster needs to have uh, three vManages, so one vManage can handle up to 2,000 WAN edges. You get that? And vManage can also use like multiple authentication methods as well, including radius and tags and all. And by default, vManage is deployed in a single tenant mode. Though we're going to talk about what's tenancy and what's multi-tenant and all those things. These concepts are going to come there. But yeah, it's just an information that it's a single tenant mode. And
Uh,
if the requirement call for the support or service provider model, then
Abhijit,
multi-tenancy also is
yeah,
supported. Yes,
uh,
Debashish?
yeah, Abhijit, is this vManage manage the CH also?
Yeah, of course. If
Okay,
there is like vManage is basically a controller that manages all the devices that's out there in the SD-WAN fabric. Be it CH, be it VH, be it vSmart, be it vBond, everything it can be controlled directly from the vManage itself.
okay. And other thing, you said about the REST API. Is the REST API is integrated with this vManage? How it is
Yeah,
how
yeah,
it,
it is integrated.
and on that it Python and all can be used?
Yes, you can use Python and all to
Okay.
configure the vManage.
Okay. Can you in later maybe on that? Can you show one or two example of that how it do
Well,
or
I'll describe you that how it actually works in a practical way possible. Okay, but in order to learn
okay,
that, you I need to give you an introduction to REST API and how it actually works and all. There's like altogether a different dedicated course for SD-WAN programmability.
okay, that's fine. But at least one example of
Yeah,
something, na?
I'll
You
give
can.
you the example. Don't worry.
Okay, okay. Thank you.
Perfect. So yeah, that's exactly how vManage works. Now, all configuration for the SD-WAN fabric should be performed within the vManage itself in order to maintain the consistency and scalability in terms of that. Okay, and when we think about how the SD-WAN actually fabric can be bought out, we're going to talk about that in onboarding and all that processes. But yeah, the vManage can actually be built up by creating like via creating features or CLI templates or so, or by creating policies controlling things such as like network topology or routing or quality of service and security and all. All these things are configured inside the vManage itself. So when necessary, when it is necessary, then vManage is also where like the troubleshooting and monitoring of the entire network will be done. And network admins can actually simulate traffic as well to show how data is actually performing and so on. Yeah, that's what you can say, Romal. It means that we manage reflect like single pane of glass there. So you can say that whenever like if there is a vManage cluster that is in place, or like each vman or each vanage will have to form a single management like plane connection with vManage. Okay, as I told you that the vanages with each other, they form kind of data plane connectivity. So if I give you a topological overview of something, then you can say that these are, let's say, three vanages that you have. So you have this, you have this, and you have this. And then there is this controller called vManage, and then there is this controller called vSmart. Cool? So your device is gonna build up a tunnel over here and a tunnel over here. Cool. And then you have like a transport there, which is ISP transport. Doesn't matter which type of internet is being used there, or doesn't matter which type of connectivity is being used there. So in that case, consider that ISP is being like taken into consideration when connecting with the device over the. I'm just giving an overlay topology. Look, so your vanages are going to have a management plane connectivity, and your vanages are also going to have a control plane connectivity with the vSmart, and then the vManage and vSmart are also connected together by using them. So what happens is if you want to configure your device, you can actually directly deploy configuration on this as well, or you can deploy the configuration by using vSmart if that's a routing configuration and so on so. Okay, so all that configuration will actually be sent by vSmart if it's a control plane connectivity or if it's a control plane configuration that is being done. Okay, otherwise you can also provision your device by using that management plane connectivity, based on which your vManage gets to know about the health of the device and all the other parameters there. Cool. So each WAN edge, as I said, will form a single management plane connectivity to vManage. And if the device has multiple transports available, then only one transport will be used for the management plane. And if there is any cluster of vManage that is set up, then the control connection will get like load balanced across the cluster nodes. But still, it's gonna be like one like single management plane connection that's gonna be there. Doesn't matter how many vManages that you have there. And if like a transport hosting the management plane connection experiences an outage and all, then a vAnalytics will briefly lose the connectivity with vManage, and then any change that will be made will get pushed to the device whenever the device reconnects to that particular like to the vManage again. And if you look at the last option that's available, there is also something called like if you look at the menu here, then this option that's available there, this is called as vAnalytics. Okay, this is called as vAnalytics. And vAnalytics gives basically the network admin kind of a predictive analytics to provide actionable insight into the WAN also. So with like vAnalytics, you can say the business can perform like trending or capacity planning and how the device is performing, and also based on the history of the device's information and all, you actually get to know that how the WAN is performing also. Good. So that's what a vManage would basically look like. And yeah, so that's basically the information that we have for, you can say, management plane, and that's how management plane is actually operated. Any questions there for vManage? Do you understand that? Please reply in chat. Are we good with management plane? Okay, I think we're good with management plane. Then the next thing that we want to talk about is going to be the control plane. But yeah, let's take a 5 minutes off, and then we'll continue about control plane information that's gonna be there. Right? I'll see you in 5 minutes. Thank you. All right, guys, I am back there. So let's talk about control plane and how it actually works. That's gonna be the next thing there. I hope I'm audible there. Am I good? So talking about control plane. Now, earlier we learned about how control plane has been separated from the data plane in the traditional sense, right? But the component over here, when we talk about control plane, it provides all of its functionality, or control plane is taken up in terms of responsibility by a controller called vSmart, as I told you, right? And vSmart is basically, you can say it's kind of a brain of the SD-WAN fabric. So vSmart is highly scalable, and it can handle up to something called 5,400 connections, okay, per vSmart, and with up to like you can say you can deploy maximum 20 vSmarts in one production environment. Okay, there can be 20 vSmarts, and each vSmart can handle 5,400 control connection. It means that it can have connections up to 5,400 WAN edges. Okay, one vSmart. And with these numbers, you can say the deployment can support very large WAN environments. And vSmart is responsible for implementation of control plane policies and centralized data policies and service chainings and VPN topologies and handling all kind of data there. Which actually needs to be like provided from control plane to the data plane. Okay, and vSmart also handles the security and encryption of the fabric by doing the key management. So you see, whenever you build up an IPsec tunnel between R1, let's say, and R2, let's say these two are WAN edges, and you want to build up like a VPN tunnel between these two devices. So if you're using IPsec, then there will be key encryption that's going to be done on R1. And then there is going to be key encryption that will be done on R2 as well. And then both of these routers will also need to do key decryption as well, right? Encryption, decryption, both happens at both the devices. But in that case, if you have connectivity with around like, let's say 30, 40 or around 500 devices all over the globe, R3 and R4 and R5, and you need to build up like VPN tunnels with every device, like this, like this, like this, right? And even if you have like something like DMVPN or kind of a hub and spoke topology, okay, where you have a hub and then you have different spokes there, and that's how you build up like VPN connectivity with other branches. There are multiple options that are available, right? Even in these all these options, the encryption and decryption for every VPN tunnel needs to be done on a local router, and that also like consumes a lot of processing power there. But if you look at the control plane management that is done in SD-WAN fabric, this rekeying or this encryption decryption is basically something that is handled by vSmart itself. So your device or vManage doesn't need to go through the key management of the tunneling system there. Okay, so IPsec key management is done by the vSmart itself. And when we talk about separating the control plane from data plane, then this separation of control plane and data plane management allows the solution or the SD-WAN fabric to achieve greater scale while like simplifying the network operations around. So if you look at the traditional link, or if you look at like how traditional link state routing protocols work, such as OSPF or even EIGRP or something like that, each router knows about the state of the whole network and calculates its own routing table, right? Based on like the information that has been provided inside the database table of OSPF, if we are taking OSPF in consideration. But this can be like very CPU intensive task because every router needs to calculate the best path by using the SPF algorithm according to its own needs, right? And that kind of consumes a lot of processing power of one router. And uh, you can say that the distance vector routing protocols they operate a little like differently in that scenario, that they only know about what their neighbors will tell them. That's how distance vector protocol will work, right? But in turns there may be like issues like suboptimal routing, right? Like the traffic is going one way but it's coming the other way. So such kind of issues can actually be there. But with SD-WAN solution, all the routing information is learned by all the vSmarts that are available. It can be one vSmart, it can be multiple vSmarts, and all the vSmarts are gonna you can say learn about that particular router. You get that? So the routing table is maintained completely by vSmart itself, and you can say that then vSmart calculates the routing table for each WAN edge's perspective, and they distribute it to the WAN edge that's available there. Now, because the vSmart has the complete picture of the network state, you are basically simplifying the best path calculation for every WAN edge that's out there. They don't really need to do the best path calculation. and it kind of reduces the like very good amount of complexity of the entire network that's out there. While they all still are you can say increasing the scale of the scalability of the fabric. Cool. So vAnalytics can connect like a single vAnalytics, one WAN edge can connect up to three vSmart. It can have a connection with up to three vSmarts there. You get that? And whenever the connection is actually being done, it will completely be a different like connection that's being managed, to which we call as control plane connection. So vAnalytics can connect up to three vSmarts at a time, but it only needs connectivity to one vSmart to get the like information or control plane information dispersed over there. And all this information, like the protocol that the vSmart uses to communicate all of this information, is called as OMP. OMP stands for Overlay Management Protocol. However, there is a separate, like altogether a specific section about how OMP works and all. But yeah, in this section, we're just gonna like talking about how OMP actually works. Cool. So though OMP handles like routing and all, it would be like it's not simply a routing protocol. It does all the other like it does very apart from routing, it also takes care of multiple things there. Cool. Like OMP is used for managing like to manage and control the overlay beyond just like routing, like key management and configuration updates and policy information dispersal and BOD information keeping and all these other information is actually managed by OMP, or all the updates that like whatever communication is done between vSmart and vManage, it's all done with the help of OMP itself. Okay, and OMP runs between vSmart and WAN Edges inside of a secure tunnel. So when a policy is built via the management plane, like vManage, then the policy is distributed to the vSmart. Okay, and then the vSmart will distribute that particular policy by using OMP to the WAN Edges. That's exactly how the communication will be done. So do you see the tunnel that is being built over here between the vSmart? In that tunnel, the information will be sent in a form of an OMP update there. Okay, and then that vManage will configure its data plane based on the policy configuration, and according to that, the traffic will actually be segregated or sent accordingly. That's exactly how it works. How that makes sense to you? So the vSmart operates similarly, like a BGP route reflector, or like how OSPF works, right? Whenever there is any change in the OSPF, like whenever the link is pre-sharing basis, if you have one router there, and then if you have another router there, right, and then let's say another router, and all these routers are basically connected with the switch in this scenario, and they all are in area 0. OSPF area 0. So in such scenarios, if there is any change in R1's routing table, the R1 will actually give the information to something called as DR, right? Designated router. And if this is a BDR, backup designated router, then the information will be provided to the DR and BDR both. But only DR will be forwarding that change onto all the other routers that are member of that area. Correct? Similar thing happens in BGP as well. So when the vSmart receives routing information from each WAN edge, and it can actually apply its policies before advertising this information back out to the other WAN edges. So vSmart is also where like different topologies are kind of defined. Like per VLAN topology definition can also be different there. So the control policy is defined in the management plane, and then the management plane distributes that particular policy to, and vSmart applies that particular policy to the fabric. So you can say that the topology modification is achieved by manipulating the information there. And the control plane is also like responsible for encryption of the traffic and everything. So in more legacy WAN technology, you can say that securing the network that is required like a considerable amount of processing power and so. But as each device would compute its own encryption keys and distribute all these key pairs like using IKE, Internet Key Exchange protocols, and so on. So all these things are also taken care by the vSmart, so that the processing power can actually be lowered down there. Okay, that's how the thing is actually done. Cool. And if you yeah, so that's how the thing actually works in control plane. And we, however, will be like spending a lot of time getting to know about control plane and data plane separately. But yeah, then there is kind of a new plane that's available, which is called as orchestration plane. And the orchestration plane is something which takes the information, or which takes care of something called vBond. Okay, so when a vanish first joins the overlay, the only thing it knows about is the vBond. You see, when I told you that it's gonna like it's probably the most important component I can say in v like which is vBond, because this component is so important because it provides the initial authentication for participation into the fabric. So whenever you have a vanish there, then this vanish first is going to contact to PNP or ZTP. And PNP and ZTP will give the information that, let's say 200.1.1.13. This is an IP address of the vBond. So then the vanish will go out to that vBond. And then if the certificate, like if it authenticates itself, we were going to talk about what authentication method does it use and all and all. It's not like the thing that we're going to discuss now. But yeah, when vBond kind of authenticates that okay, the vanish actually belongs to the organization, then it gives the information that vSmart is situated on this IP and vManage is situated on this IP. And then by doing the certificate validation and all, it actually connects with vSmart and with vManage. And that's how the vanish becomes up. And then once these vSmart and vManage discovers that the devices are, then the policy enforcement is sent and the device configuration is sent onto the device or through here. Okay, we'll talk about what information does each and every controller sends over there.
Abhijit,
So,
after discovering the vSmart and vManage, is required the vBond connectivity for the V edges, and what will do
no,
after that?
can you repeat that? Can you repeat that, please?
Yes, after discovering the vSmart or vManage by V edge,
Uh-huh.
is it required vBond connectivity with the V edge, or it
No, it's
further
fine if
in
it's broken down. It's fine if it's broken down.
after just assume that we have the power outage and vSmart V edges reloaded. At that
Uh-huh.
time, how it is going to connect?
No, so it's gonna form up the connectivity because the certificate validation is done, right?
Certificate validation is done. Okay,
Yeah.
okay.
So we manage and like vBond is just used to make sure that the vanish is part of the organization and part of the fabric. So once it is installed inside the vManage and vSmart inventory, then it's not gonna be like a remote from the fabric.
Mm-hmm. Okay, thank.
Yeah. So you can say though vManage can like point to only a single, like multiple vMont servers can actually also be deployed to achieve like high availability options and all. And if you say like to have a vManage, like you can say that a vManage or can actually point out to the PNP or it can be point out to the ZTP as well. But there are multiple options that are available for configuring a vManage. So when a vManage kind of first joins the overlay fabric, then you can say the only thing it knows about is the vBond. Okay, so it receives this information about where is this vBond situated by these four methods. So it's gonna get the information from either plug and play or from ZTP or from bootstrap information that you can load up or from manual configuration. So you can configure your vanish with these four methods, and then the vanish will kind of attempt to build like a temporary connection with the vBond over the each transport. Okay, it's gonna try the transport. It's gonna try build out the connectivity by using either the MPLS or by using the internet and so on. So, and once the control plane connectivity is up with vSmart and the management plane connectivity with vManage, then the connection to the vBond will be torn down automatically. Okay, so at the time of that particular vanish connects to the vBond, It goes through the authentication process, and each component authenticates like each of like everyone itself. And if it is successful, then there is something called DTLS tunnel, or it can also be a TLS tunnel. Okay, so by default you can say DTLS tunnel is established, and then the bond then like distribute the vBond then distributes the connectivity information to the vSmart and vManage, and that is exactly why the vBond is essentially referred to as the something like the authenticator of the entire fabric that's out there. Okay, this is yeah, that's exactly why vBond is the most important thing that's available there. And it also recognizes whether your device is behind NAT or not.